Okay, everyone. Have a 60 minutes. Making good attention. Okay. Now we have seen a few examples here, right? We did this in detail yesterday, right? Whenever the force is mg, it makes an angle. Theta is going to be the angle of the inclined plane. Then this component along the inclined plane will be what? Mg sin theta, and this will be what? Mg cos theta, and normal reaction will be perpendicular to the surface. Normal reaction will be balanced by what? Mg cos theta. And because the body is moving with an acceleration A, it is what frame? Non-inertial frame. Because it is a non-inertial frame, I have to assume a pseudo force in the opposite direction, which is equal to what? Ma. And if I resolve Ma into components, then this will be Ma sin theta and this will be Ma cos theta. Ma cos theta will be balancing what? Mg sin theta. And in fact, because of the pseudo force, normal reaction is now balanced by Ma sin theta plus Mg cos theta, that we will see later. What is important right now is Ma cos theta is balancing Mg sin theta so that the block is in equilibrium. It does not slip. So if you equate Ma cos theta to Mg sin theta, M gets cancelled. A cos theta is equal to G sin theta, so A is equal to G tan theta. This we had seen yesterday. And we had also seen a few more examples where this happens, right? So if I observe, right, when a car or a vehicle is moving to the right, it's common sense. You can understand that the pendulum will swing to the back, correct? So that's because of the pseudo force. Ma is Mg. Similarly, when the vehicle is moving to the left, what is going to happen to the bob which is connected to the string? It will move to the right. All right. If the car is moving with uniform velocity means what is acceleration? Uniform velocity means what? What is uniform velocity? Velocity is constant. If velocity is constant, what is acceleration? Then there is no force, right? No pseudo force. Therefore, the pendulum will not swing to the back or front. So if the car is moving at uniform velocity, the position of the bob does not change. The car moves with an acceleration or retardation. The bob moves in the opposite direction. If it is accelerating forward, then bob will move backwards. If the car is slowing down, then it will move forward. This is just an implication of inertia, correct or not? You understand it a little more here. So if you observe here, this also we did yesterday. So when the bob is here, it is connected. Tension is acting on the bob. Then what is acting downwards? Mg. And let's say the vertical angle is theta. Then what will happen, students? This will be theta. So this component on the vertical side will become E cos theta. What is the component on the horizontal? E sin theta. This resolving, we have already seen quite a few times now. And Mg is acting downwards. Ma is acting what? To the left. This means the car is what? Accelerating or decelerating? Accelerating. That's why it's accelerating means it's moving to the right. Therefore, the bob is moved to the left. Okay, fine. So for equilibrium, if you see, what is balancing Mg? T cos theta. What is balancing T sin theta? Ma. So once again, you are getting the same expression when you divide the two equations. Tan theta is equal to A by G. Okay, let's look at question here. We will ask somebody for an answer. Yes. Yes, sure. Yes, sure. Try this one. A ball is suspended by a thread from a ceiling of a tram car. Brakes are applied. Brakes are applied means what? Is it deceleration or acceleration? Deceleration. That means the bob will move to the front or back. Front. Very good. So it will make an angle theta, let us say. The speed of the car changes uniformly from what? 36 km/h to what? 0 in how much time? 5 seconds. Okay, now tell me, we want to write everything in SI. So 36 kilometer per hour. You want to convert it into what? Meter per second. So what is the best way to do it? Into 5 by 18. Very good. If you multiply 36 into 5 by 18, 36 and 18 will cancel 2. 2 into 5, 10. So 10 meter per second to 0. So what is the change in velocity? 10. What is the time? 5. So can you tell me the acceleration? 2. Very good. 10 divided by 5 is 2. Change in velocity is what? Initially it is 10 meter per second. Finally it becomes 0. The car comes to rest. So 10 minus 0, 10. 10 divided by 5, how much? 5 seconds. So change in velocity by time is acceleration. So acceleration becomes equal to, yeah, so what is acceleration? 2 meter per second square. Very good. Now, so you got the acceleration. Now what is G, ma? Okay, what is G? 10 meter per second square. Now the question is, what is the angle by which it deviates from the vertical? So we saw the expression already. What is theta? What is tan theta? Let's see here. You don't have to do the derivation in your mind now. If you remember the expression enough, tan theta is equal to A by G. Tan theta is equal to what? What is A? 2. What is G? 10. So tan theta is equal to 10, 2 by 10. What is it? 1 by 5. So 2 theta will be what? Tan inverse 1 by 5. So which option? Third option. Okay. You go to another notes. I hope you understood what I said. Change in the speed of the car, 36 km per hour to 0. Either directly you can do 36 kilometer is 1000 meters. So 36,000 divided by hour. Hour runs how many seconds? Not 60 seconds. 1 hour is 60 minutes. 3,600 seconds. So you can directly divide that, you will get 10 meter per second. Acceleration is v minus u by t. When you substitute that, you get 2 meter per second square. Tan theta is a by g. Already we saw. So it's 1 by 5. Tan theta is 1 by 5. Then theta is equal to tan inverse of 1 by 5. So that's the third option. Start converting your kilometer per hour to meter per second. So instead, you could also do what he was telling. Just simply multiply by 5 by 18. What is 36 into 5 by 18? 10. You can do that also. You know, we come to a very, very important aspect which is required for any numerical that you have to touch in Newton's laws of motion. You need to know this. It's called free body diagram. Already we did this in yesterday's session. When I was explaining the concept of inertial and non-inertial frame, I was doing, right? For the bulb, I was writing the equations, correct? That is called free body diagram. And we were also doing for the horse. Do you remember? We replaced the horse with a dot, correct? And we wrote down all the forces which are there. That is called free body diagram. We'll quickly go through some rules for free body diagram, and then we'll move on to questions which are there. Okay, now you can see when a number of forces act on a body, the resultant force on it produces acceleration in the direction of the resultant force. For example, you have a mass which is connected by a string to ceiling. Now, can you tell me what are the forces on this mass? We did for the bulb yesterday. Yeah, acceleration due to gravity is there. Because of that, mg, gravitational force, will act which direction? Downward direction. And what is the force in the upward direction? Tension, because it is a string. So these are the two forces, right? So whatever may be the body, I will make it into what? Point. And then I will simply write the forces alone. This method is called what? Free body diagram. So when the number of forces are acting on a body, resultant force is calculated, which is going to be producing an acceleration. So do you remember yesterday? The lift was coming down with acceleration A. So what did I do? mg acting downwards on the bulb. Upward force was what? Tension. Outside I wrote what? Acceleration. So mg minus tension is equal to ma. Do you remember? Yes. Same thing. That is what is mentioned here. So when a number of forces act on a body, the resultant force. What is the resultant force in yesterday's example? Or even in this example, tell me which is the resultant force. Suppose if it is going down. If it is going down with an acceleration A, which is greater, mg or tension? Mg. So you should do what? Mg minus T or T minus mg? Mg minus T. So mg minus T will be equal to m into A. So the force, resultant force, will be in the same direction as the acceleration. That's all. That's the first point. Second point, an object of mass m is suspended vertically. That's what is explained in the figure. Tension is T equal to mg. Because why we wrote T equal to mg here? The body is in equilibrium. Is it moving up and no, right? So tension equals mg. What is the net force in this case? What is the resultant force? 0. Okay, next. Now we are coming to what we discussed yesterday. Suppose the setup is inside a lift and the lift is moving with an acceleration A upwards. If you remember yesterday's expression, when the lift was going downwards, what was the expression we derived for tension? Tell me. M into G minus A when the lift was going down. Now the opposite is being asked. What is happening? The lift is moving upwards. Then what will be there? It will be T into T is equal to what? M into T plus A. If the system is moving downwards with an acceleration A, then the tension will be what? T is equal to M into G minus A. Okay, man. Now, suppose if the system is not accelerating, then what it will be? A will be 0, therefore tension will be equal to M into G. That's all. Okay. Because few of you were absent yesterday, I will just explain this concept once on my board and then we will move on. Okay, there are quite a few things that we need to cover today. I want your full attention and cooperation. Listen, ma. Listen. Thank you. Can you explain the situation? What is happening? Yes. Prithvi, can you explain what is happening? A mass is hanging. Let's say this is a lift. Tell me now. A mass is hanging inside the lift, and what is happening to the lift? Going down with acceleration A. So is it non-inertial frame or inertial frame? Is it accelerating or non-accelerating? Accelerating frame. We cannot apply Newton's laws, correct or not, directly. So either we have to assume a pseudo force or I have to write it from outside. Have a seat. So let us write it from outside. Now I'm going to draw the free body diagram. So when I'm talking about the free body diagram, I will consider this mass as a point. What are the forces acting on this mass? Yes, Enoch, tell me. Tell me. Mg downwards, yes. Tension upwards. Please tell them. I don't want anybody to be talking there, Zubair. And what is your name? Yeah, please, Zubair, come here. Come to the front. Sit here. Tell me, Enoch. So there is a tension in the upward direction. Okay, either you must assume a pseudo force, or what you can do is you must do this experiment from outside, correct or not? Which means, what is the acceleration on this, A, and it is acting in which direction? Downward direction. So the resultant acceleration The result in acceleration is in the downward direction. So can you tell me what is the net force? Yeah, net force, yeah. The downward force is greater than the upward force. So what is mg? Yeah, that is ma. Net force is equal to ma. Very good. Yeah, and what is net force? Or what are the forces acting on the spot? Mg tension upwards, mg downwards. That's all, right? Now, what is the resultant force? Among the two, there are only two forces acting on it, mg and tension. So what you should do to those two forces to get the resultant? Mg minus t. So net force is nothing but mg minus t. What is mg minus t equal to? Ma. Take t to the other side, bring ma to the side. So what do you get? Correct. What is tension equal to? M into G minus A. You are going to have applause. So now do you understand, students? So tension is equal to M into G minus A and the lift is going downwards. Is that clear to you? Okay. What is the condition for free? Okay, I'll ask somebody. Yes, Gautam. Of course, I have not told you this, but if you can think about it and tell me, what is meant by free fall? Yes, in the sense, if you see, right, God forbid, but still, suppose if the wire of the elevator, right, the string which is responsible for holding the elevator intact, right, gets cut. What do you think will happen? The elevator will just fall under gravity, correct? If such a thing happens, and let's say somebody is inside, what will that person experience? Weightlessness. Who said that? Very good. Excellent. Give a good round of applause. Okay. Weightlessness they will experience because of what? In the sense, suppose let's say a bulb is hanging there or a mass is hanging there, that will also experience what? Weightlessness in that situation. I want one answer. What is A in that case? What is the acceleration of that lift in that case? Sit down. What is acceleration? Yes, acceleration will be G. Very good. Give a round of applause. So the acceleration will be G. So if you substitute A as G, what is G minus G? No, what is G minus G? A is also G, 0. So the tension will be 0. That means the bulb will feel weightlessness. Or in other words, suppose the man is standing here, For him, somebody can tell me what is going to be the, equations or the forces which are acting. Yes, you want to try? For the man. Let's say I want to tell me. Mg is downwards, very good. He is standing on the floor of the lift. What is balancing mg? Good. I was asking him. Huh? I can't hear you. Is he hanging? Sit down. Get up, come on. Normal reaction, okay. Only hanging objects have tension, guys. Nothing wrong. You make a mistake and learn something. Okay, so what is there? Whenever an object is on the ground, what force does it experience? Normal reaction. Mg is down and normal reaction is acting upwards. Yes, now tell me, Jerome, get up. Now you know the two forces which are acting, right? But what is happening to the man? He's going down or he's going up or he's there? No. We don't know. What do you know from the diagram? Is he going down or going up? He's inside the lift here. He's inside the lift. What is happening to the lift? Yes. If the lift is going down, where is he going? No. Assume that you are inside a lift in your 4th floor. From 4th floor, you are coming to ground floor. You are coming down, right, along with the lift. Okay. You understand? We are doing the same sum without applying pseudo-force. I'm saying without using the concept of pseudo-force. I understand where your answer is coming from, right? But we are standing outside and writing the equation, so there is no problem. So somebody was telling you, the pseudo-force, that word is, don't worry. Okay, you are applying. When you are doing outside and writing the equations, you're basically, another way of doing it is sitting inside and applying pseudo-force. That's all. Okay, ma, tell me now. Yes, tell me, Jerome. So mg is acting downwards, normal reaction is acting upwards. These are the only two forces acting on the body. And what is the resultant acceleration? In which direction? Downwards, correct? Now, what is Newton's law? Net force equal to ma. Net force on this man is equal to ma. And what is net force? Mg minus mg minus n, because mg is acting downwards, n is acting upwards, so the resultant force is so what is n equal to? Mg minus n. N you are taking to the other side, so it will become you take m outside, what do you take? G minus n. So do you understand? So one important point at this point, it can come for 1 mark, right? Whenever a lift is going down with an acceleration a, a person inside the lift feels his weight to be less or more. Yes. Why? Because he only feels normal reaction. Because it is G minus a, it is not mg. His actual weight is what? Mg. But how much he is feeling? M into G minus a, less than that. Therefore, when the lift is going down, accelerating down, he feels less weight. Clear? Now, the situation which happens, let's say it happens. Let's say the string which is holding the lift is cut. Now, what will happen? It will have a free fall. When it has a free fall, what is that A? Are you able to visualize? When it is freely falling, what will be that A? A will also be G. So if A is G, substitute that A in this equation. So what do you get? G minus G, 0. So normal reaction will be 0. So he will experience what? Weightless. Good. You have a good round of applause. Okay, now next. This is just a revision for students who have missed it. Clear, students? Now we move on to the next topic or next, right? You can tell me the equations here. Who would like to tell? Surely you want to try? Come on. So for that mass which is hanging from the wall of the lift, can you tell me what are the forces acting on it? Mg in the downward direction and tension in the upward direction. Perfect. Now, is there any resultant acceleration? Yes. In which direction? Resultant acceleration. In which direction? Upward direction. Correct. Now tell me, two forces are acting on this body, right? What are they? Mg and tension, which is greater? Tension. Why? How do you understand? How do you conclude that? Because it's going up, right? Very good. Going up with an acceleration. Excellent answer. So tension is higher, correct? Okay, now are they opposite in nature or they are supporting each other? Tension and Mg. Opposing, right? So should you subtract them or add them? Opposing. What do you do? Subtract them. So is it Mg minus T or T minus Mg? T minus Mg. Very good. MA. Very good. Net force is equal to MA. Good. What is tension equal to, Shalin? Mg plus MA. Mg I'm taking to the other side. So what is the conclusion? When the lift is moving up, the effective acceleration is not G. How much it is? G plus A. When the lift is moving down, what was the effective acceleration? G minus A. Very good. Okay. So now let's do it for the man. Okay. So anyway, give a good round of applause. For the man. Let's say the mass of the man is capital M. Now, can you tell me what are the forces acting on the man? Very good. Normal reaction is acting in the upward direction and Mg is acting downwards. Perfect. Okay. And is he moving down or up? Up. The accelerator is moving with an acceleration A. So resultant acceleration is A. In upward direction. Now, what is Newton's law? Net force is equal to M into A. And in this case, two forces are acting, normal reaction and Mg. So what should we do? N minus Mg is equal to Ma. Excellent. So what is M equal to? What is N equal to? Mg plus Ma. I can take M out. So what do you get? T plus A. Excellent. Perfect. Perfect. Excellent answer. Now, thank you. You got a round of applause. Now, 2 points to be driven here. Point number 1. When the lift is moving up with an acceleration A, the effective acceleration is what? Is it G, G minus A or G plus A? G plus A. The first bench, not to talk. I've invited you to the front in order to, so that you listen better. Okay. So G plus A is the effective acceleration. Clear? And now tell me one more. Can you answer one more question, Roshi? When the normal reaction is what this man will experience, correct? The man places his weight on the lift, right? Mg is experienced by the lift. What the lift imparts on man is normal reaction. So he will experience normal reaction. So will he feel heavier when the lift is accelerating up or lighter? Heavier, exactly. But when the lift is going down, what will be the equation? N equal to M into G minus A. So he will feel what? Lighter, not weightlessness, lighter. But suppose if the string is disconnected, then A will become equal to G. At that time, G minus G will become 0 when he is coming down. At that time, he will experience what? Weightlessness. Right? Good. One more round of applause, students. Good. Okay, this is what we were discussing. Now, I will ask another question. Okay. Yes, you want to try? Now, can you write the equations for acceleration will be 0? Which will be mg? No, what is mg? Tell me the equation. Okay. You were absent, right? Griffin, you tell me the equations in this case. Hey, he gave part of the answer, okay? So give a good round of applause for one of the parts. I will tell you what it is, okay? Yes. No. Tell me first. Draw the free body diagram of. Forces acting on this. Sorry? Yeah, tension will act upwards. Downwards, mg will act. Very good. Yes. Sorry? V is there. The elevator is moving upwards. No doubt about it. That's all. Okay, good. No problem. Give a good round of applause, students. Okay, so mg acts downwards, tension acts upwards. But important point to note here is velocity is constant. Therefore, acceleration is a is 0. Net force is equal to m into a. Because a is 0, this will be 0. What is the net force? You can either write mg minus t or t minus mg, does not matter here. Okay, so in this case, you will get tension is equal to mg. When the lift is stationary, what will you get? Same tension equal to mg. Okay, I'm okay. Okay. The element is moving down with constant velocity. Let me write that. Now, can you tell me what are the forces acting on this man? Yeah, what is gravitational force? mg downwards. Excellent. Normal reaction upwards, correct? It's moving with a velocity v. What can you say about the acceleration? 0. Excellent. According to Newton's law, what is net force? No. Net force is what? Mass into acceleration. Mass into acceleration. MA. But in this question, just like the previous question, acceleration is 0. Therefore, MA will become 0. And what are the forces acting on this mass? mg downwards and normal reaction upwards. They are opposing or supporting each other. They are opposite in nature or opposite. So you should do mg minus n or mg plus n. Mg minus n, correct? Or you can even do n minus mg, doesn't matter. But no. You can't do. I asked a different question. I asked mg minus n or mg plus n. It is not mg plus n. It is what? Mg minus n. Or even you can write it as n minus mg msec. That's all. Both are right. Because they are opposing in nature. Mg minus n is equal to 0. So what is n equal to? So he doesn't feel any change in, any apparent change in his weight. Good. You have a good round of applause. Five things I'll tell you. Okay. We are quickly summarizing what we have learned now. First, case number 1. A lift is accelerating upwards. What is the effective acceleration? Is it G? Is it accelerating upwards with acceleration A? So, what is the effective acceleration? Is it A? Is it G or G plus A? G plus A. What is the normal reaction going to be? M into G plus A. What is the tension in the string of anything which is hanging? M into G plus A. When a lift is moving down with an acceleration A, then what is the effective acceleration? G minus A. Now, when a man is in the lift and he is coming down, the lift is accelerating with an acceleration A, then what is his normal reaction? M into G minus A. So he feels apparent loss of weight when it is coming down, or gain of weight, or same. Apparent loss of weight when it is coming down with an acceleration A. When the lift is going up with an acceleration A, the man is going to experience apparent gain in weight, because his normal reaction is tension into, mg into M into G plus A. If the lift is stationary, what is normal reaction equal to? Mg. If the lift is stationary for an hanging object, what is tension equal to? Mg. For a lift which is moving downwards with a constant velocity v, what is tension for a hanging object? Mg. Was A 0? What is normal reaction? Mg. Because A is 0. For a lift which is moving upwards with velocity, constant velocity, what is tension? Moving up with constant velocity. What is the tension? Mg. Because acceleration is 0 in this case also. Constant velocity. Then lift is moving down with constant velocity. Mg again. Now I'll ask a googly question. Who is ready to try? Enoch, get up. I've already told it's a googly, so you can be prepared. Okay. I'll first ask straight questions to you. Okay. Then I'll go to the googly so that you can understand the difference in what I've asked. What is the normal reaction of a man of mass capital M when he's inside a lift which is moving up with an acceleration A? N is equal to M into G plus A. Excellent answer. Now I'll ask another question. When the lift is accelerating downwards with an acceleration A, what is his normal reaction? M into G minus A. Now the googly question coming up, okay? The man is inside the lift. The lift is moving up with a retardation A. What is it otherwise, normally? Excellent answer. Excellent. Give a good round of applause. Can you explain? Can you explain once to everybody?
So, since the formulas for body moving upward is the normal reaction of a body moving upward is n into m into n is equal to m into g plus a, and since the acceleration is retarding, it will be minus a. So n into g plus minus a will become n is equal to m into g minus a.
Excellent answer. Give a good round of applause. Clear, students? So when the lift is moving upwards with an acceleration a, normal reaction will be m into g plus a usually. But because of the retardation, that means the velocity is reducing. I may not give retardation word, then it's easy to pick it up, right? Not so easy, but still, you have picked it up. Instead of a, he is putting what? Minus a. So in the same expression, n is equal to m into g plus minus a. Very nicely put. So it becomes g minus a. So it is as good as what? So this guy, although the lift is moving upwards, he will experience apparent loss of weight. Very good, very excellent. So that's a googly. Okay, good guys. So similarly, I can twist the question in different ways, right? I can ask, right? One more googly. Who is ready? Don't worry about getting it right. It's okay if you're wrong. It's fine. Who is ready? One last googly. Anybody? Okay. Then I will only explain. Okay. Fine. See here. Listen. So when a lift is moving down, with its velocity increasing, when a lift is moving down with velocity increasing, what is the normal reaction? What is the normal reaction that will be experienced by the man? Or in other words, what is the apparent weight of the man? Moving down with increasing velocity. M into G minus A, that's it. Because increasing velocity means acceleration. That's all. Okay, suppose if I said decreasing velocity, then it would be what? Retardation, then M into G minus of minus A, then it becomes G plus. Okay, good guys. Okay, we'll go on. I think it's clear now. If the system is pulled up with an acceleration A, then what is the tension? M into G plus A. When it's moving downwards with an acceleration A, what is it? M into G minus A. Okay, now we go on to something a little more in depth, important. Okay, guys. So we are now looking at a new type of force. Masses connected to a string. So far, we were looking at one mass connected to the string, right? Now, what if you have two masses connected to the string, all right? Like what is shown here. You have M1 here, M2 here. So what will happen is, if there was only one mass which is connected to the ceiling, then there will be only one tension, right? This side. Because there are two masses which are connected now, there is a tension between this region of the wire, and there is also tension here. Understood or not? And in addition to that, if you are also going to apply a force, you're going to pull it down, that is going to add to the tension. Correct or not? That's what is happening here. I repeat, what is the situation here? How many masses are you having? Two masses. And these two masses are connected by string. And in addition to just having these masses, you're also applying a downward force. So there will be a tension between this mass and the ceiling, that is T2, and the tension between these two masses, the wire which is here, will have again tension. That is, let's say T1. And in addition, you're applying a force F as well. So now, can you guys tell me, drawing the free body diagram, not very challenging, but then you just have to apply yourself. So can you tell me, anybody can try the free body diagram for M1? M1? Okay. Would you like to? Okay, let me do it, please. Listen now, everybody, carefully. Okay, I have M1, which is there. I am represented as a point. Can you tell me what are the forces acting on this M1? There is a tension in the upward direction, which is what? T2. There is a tension in the There is a tension in the downward direction, which is what? T1. Sir, should T1 be upwards or downwards? For M2, it is upwards. For M1, it is what? Downwards. Because common sense. Correct? This tension is the one which is keeping this mass held, correct or not? So on M1, M2, the force is upwards. On M1, what is that wire doing? Pulling it down, correct or not? So force is downwards for M1. Any other force acting on M1, students? Gravitational force, its own weight, correct? So what is additional force? M1 into G, that's all. Clear? Does it experience F directly? No, it experiences F only through T1. So that's all. These are the three forces, only three forces. So one is M1G, one is T1, another one is T2. Correct? Now, if it is staying where it is staying, then that means it is in dash. If it is not moving, that means it is at rest. Or another word, equilibrium. We introduced that word yesterday. Equilibrium means the body is at rest. Correct? Not necessarily at rest. At least you can say net force is what? Zero. Net force is zero. So can you tell me what are all the forces acting in the downward direction? M1G and T1. They both are complementing each other or opposing each other? Complementing. So you should add them or subtract them? Add them. So what is the net force in the downward direction? Or in other words, let's go. Come on, tell me. Net force is equal to M1 into A. Suppose this body is accelerating in downward direction, that will be M1 into A. But because the body is at rest, what is A? Zero. Therefore, it is zero. And what is the net force, students? Downward force minus upward force. Or you can say upward force minus downward force, because anyways it is equal to zero. So what do you say? Come on, what is the downward force? Tell me. M1G, M1G plus T1, because both are complementing. And what is the opposing force? T2. So can you tell me the equation now? What is the net downward force? M1G plus T1 minus T2. That's it. Is that clear, students? So you have an equation now. That's all. Or in other words, you can say T2 is equal to what? T1 plus M1G. Now, can you tell me? Can you draw the free body diagram for M2, students? What is? Let's do that now. For M2, what are the forces acting? Tension is acting in which direction? For M2, tension is acting in which direction? Upward direction. And what is acting downwards? Force is visibly seen. What else is acting? Its own weight. Correct? Very good. Is that clear? Its own weight is acting down, right? And apart from that, one more force I am giving. So now tell me, can you write the equation for this? Again, net force is what? Net force on M2 is equal to what? M2 into A. But what is happening to that body? Is it at rest or moving? It is at equilibrium. So what is acceleration? Zero. So A is zero. And what is the net force? Downward force minus upward force you can do, or upward force minus downward force. What is the downward force? M2G plus F. And what is upward force? T1. So what is the net force? Tell me. M2G plus F minus T1. Very good. What is it equal to? Or how can I write T1 as M2G plus F? Little practice is required, that's all. Otherwise, it's a very simple one. So now we will move on. So you can see here, what is T1, ma? What is T1? F plus M2G. How we got it? Here. What is T2? F plus, come on. What is T2? T1 plus M1G. But what is T1? M2G plus F. So already there is M1G. So M1G plus M2G will become M1 plus M2 into G plus F. Okay. I will just do that for you if you want to understand better. Tell me, students, now. What is T1? What is T1? These two, if I combine, what do I get? Are you able to understand now? That's all. So if you can derive this, fantastic. If not, at least remember the equations. I wouldn't recommend just remembering the equation, but derive them and then remember it. Okay, students, we will move on now. Who would like to try this one? What is asked here? 3 blocks of equal masses, each 3 kg, are suspended by weightless strings as shown. If the applied force is 100 Newton, then what is T1 equal to? Very good. This is directly from what, ma? From the previous equation. So what was T1? F plus M2G, right? Here instead of M2, there is one more block, M3 also. So what do you do? M2G plus M3G. F. Do that now. So tension 1 will be equal to or simply see here, listen. It's enough to consider the lower block, right? You must have considered the lower block alone. Yes. What is the force on the lower block? 100 Newton. Apart from that, what else is acting? Those two you add, that will be tension. So what is M1? What is the gravity? 10. So what is it? 3 into 10. Plus what? So what is it? That's it. Very good, guys. You are good enough applause. Whoever thought this way. Anybody else thinking about it? Okay, now see here. Very simple to analyze this guy. Quickly, you can answer this question. Shall I tell you? Are you all ready? Okay. Now we are asked to find tension T1, correct or not? Now, what is tension T1 because of? Suppose, understand this, okay? No need to do any equation. Mentally, you can do this answer, okay? Let me tell you. Of course, in your paper, you have to write it, okay? But if it's an MCQ question, then no need, right? Here, if I cut this off, then what is T1? Tell me. If I cut this off, what is T1? No tension, correct? That wire will be simply hanging. So T1 will be 0, correct or not? So T1 is only happening because of what? Correct or not? Tension 1 is only because of what? That block, correct? On that block, what are the forces which are there? One is 100 Newton. I'm pulling it down with 100 Newton. What is another one? Its weight. What is its weight? mg. What is m? 3. What is g? 10. 3 into 10. 30. 30 plus 100. 130. That's it. Over. Or you can use the previous one we did, right? So T1 is equal to F plus M1G, which is what I did orally right now. If you want to do it procedurally, you can do this. Should I explain again? Yes? No? Yes or no? Yes, sir. See, Amma, tension 1 I want. It is because of this block. What are the forces are acting on this block? What are the forces acting on this block? 100 Newton. I'm pulling it down. Plus its own weight. What is its weight? 3 kg mass into acceleration due to gravity, G. G is 10. What is M into G? 3 into 10? 30. 30 plus 100. What is it? Or if you want, use the formula. We wrote the formula, right? Okay, students, shall we move on? Okay, we're going to go to the next concept. So before that, just please get up, everybody. Stretch yourself for a minute. Let me for 1 minute, okay? Just stretch yourself. Stretch complete. Okay, have a seat. Okay, now we will move on to motion of connected bodies. Quickly, we'll try to move through that. We have already seen contact force. What is contact force, students? Whenever two bodies are in contact, isn't it? So we saw two types of contact forces. What were they? Contact force, friction, and normal reaction. These two are the two contact forces. All right. Now, friction always acts dash to the surface, perpendicular to the surface. Friction always acts tangential to the surface. Okay. Now we have two bodies which are touching each other. So normal reaction not only acts when these surfaces are meeting, right? These two surfaces are also meeting. So sideways, normal reaction is also going to act. Are you able to understand? So if I'm trying to apply a force here, M2 will apply a force in this direction because they are in contact. Correct or not? Is it not common sense? If M2 is not there, is it not easier to move M1? Now M2 is there, so it becomes a little challenging to move M1 because it offers what? Opposing force. This is called normal reaction on 1 because of 2. So now, what is acceleration of a system? Acceleration of system is very simple. Total force by total masses. Please write down. Acceleration is equal to net force. Net force. Acceleration is equal to. You can apply this formula anywhere. Acceleration is equal to net force divided by sum of all the masses. Net force divided by sum of all the masses. Okay. So now tell me, what is the net force, ma? F. What is the total mass? M1 plus M2. So what is the acceleration of the system? F divided by M1 plus. The acceleration of the system is going to be F divided by M1 plus M2. And what is N2? Sorry, what is N12? M2A. How it is so? For M2, okay, any one of you. Aditya. For the block M2, can you tell me all the forces acting on it, ma? Normal reaction, which direction? Perpendicular direction, correct? What else? Mg, downwards, correct? So tell me, Aditya, huh? We have something else also, we'll talk about it. But first of all, is the mass M2 moving in y-axis or not moving in y-axis? Not moving, right? That means these two forces must be what? Equal. And they're equal and opposite, so that they cancel each other's effect. Therefore, the block is at rest with respect to y-axis. But if there is any force in the x-axis, it can move along the x-axis, correct? So is there any force along the x-axis? Now, it is in contact with what? M2. I'm sorry, M1. Somebody is pushing M1. So will it have an impact or not? Yes. So that contact, the surface is in contact. So there will be a force in which direction? Towards the right or towards left? No, for M2. Towards right, because he's pushing it, right? So towards right, very good. And what is that force? Is it capital F? No, assume that it is a smooth surface, no friction. Okay, no friction. I am applying capital F on the mass M1. M1 is applying another force on M2, right? That force only M2 is experiencing. And that what will be that force called? Is it not perpendicular to the surfaces of contact? So what is it called? Any force that is perpendicular to the surface of contact is called what? Tangential is friction. What is perpendicular? Yes. Normal reaction. Normal reaction not only along y-axis. Okay. Here also the surface is there, so there will be a normal reaction, and it will be same as N12. You can call it as N21. What is N21? Normal reaction force on 2 because of 1. And N21 and N12 are same. So instead of drawing all these structures, I'll only draw free body diagram. So I am representing mass M2 by dot. I don't have to mention M2G and Ny because they are cancelling each other and there is no acceleration in that direction. But towards the right direction, you are applying a force, and because of that, there is an acceleration A. And what is the only force acting on M2 in the towards right? Normal reaction. What is that? N? Very good. I can either call it as N21 or N12, doesn't matter. What is the mass of this object, ma'am? M2, right? So what is Newton's law? What is Newton's equation? Net force is equal to ma, mass into acceleration. So net force is equal to mass is m2, acceleration is a, and what is the net force here? There is only one force. What is it? What? No. What is the net force? What is the force? Yes, n12. So n12 will be equal to here. Aditi, you put round of applause. So that is what you are seeing here. Are you able to understand now? So what is n12 equal to? M2A. Did you understand now? Yes. So N12 is the contact force between M1 and M2. If you write it as N12, it is force on M1 because of 2. If you write N21, it is the force on 2 because of 1. And both are equal and opposite. When you say N12, you take it in the left hand direction. But when you take N21, you take it in which direction? Right hand direction. I have here mentioned N12 synonymously to N21. But you can understand what they represent. Is it clear, students? We move on. Now we have 3 blocks. Now tell me, ma'am. How many normal reactions will be there in the horizontal direction? Let's forget the vertical directions. Here vertical direction M1G will be there, normal reaction will be there. M2G will be there, normal reaction will be there. M3G will be there, normal reaction will be there. Those we'll forget. They are all in the y-axis, and net acceleration in y-axis is what? 0. But let's say I'm applying a force F. I'll ask a couple of questions, okay? First question. Shreyas, I have the total force. What is the total force? F. What is the masses? M1, M2, M3. I want to find acceleration of the system. What is acceleration? Acceleration is given by what? Force is what? Tell me Newton's second law. Force is mass into acceleration, correct? So what will be acceleration from that equation? F is equal to ma. So what is A? F by M. Force by mass. So you know the force here. You know the masses here. So what will be the answer? F by tell me the definition, students. What you wrote for acceleration? What did I tell? Net force by sum of all the masses. Sit down now. Now tell me. Clear? You don't have plots. Sit down. So what is acceleration? Acceleration of the system is what? F by M1 plus M2 plus M3. Okay. Now tell me one thing, students. Now tell me, what is the acceleration of the system? A. What is the acceleration of M1? What is the acceleration of M1? What is the acceleration of M1? I don't know. I will not answer now. Let's say, you can tell me. What is the acceleration of M2? If I employ M1 plus M2. What is the acceleration of M3? Okay. What is the acceleration of M1? What is the acceleration of M2? Sit down, everybody. Okay, ma? First rule in applying Newton's laws, free body diagram, is all the elements in the system have the same acceleration. Did you do that yesterday or not? So what is the acceleration of M1? A. What is the acceleration of M2? A. What is the acceleration of M3? And what is A? F by M1 plus M2 plus. Yes. Okay, good. Next. Fine. What is contact force between M1 and M2? Let's call it as N12. What is the contact force between M2 and M3? N2, 3, right? Now, tell me students, tell me what is the contact force between M3 and M2? Anybody tell me? What is the contact force between M2 and M3? Anybody? Quick. Very easy. Huh? N23 is the normal reaction. Can you tell me what is going to be the force on M3? Force on M3. And what is N23 equal to? Tell me. Usually call it as N32, doesn't matter. Huh? M3A. Give a good round of applause. Can I ask one more question? It was an easier question. One more question I'll ask. No, answer. What is the normal reaction between N2, M2 and M1? N21, okay? N21 we'll call it. What is it equal to? N21 will be equal to? Okay, now if you see, there is also a force which is there. M2A. Okay. M2A. Okay. Let's do it, guys. I'll do it in detail for you, right? But you can pick it up. You can pick it up. You can remember the result. We will also see what is being presented. Okay, first I'll do it for you guys. Okay, now, so you are applying a force F on M1. And what is the force back? N12. Okay, now, let's draw the free body diagram for M1. You see, isn't this the free body diagram of M1? Correct or not? Isn't this the free body diagram of M1? I'm skipping something here. What I'm skipping? What I'm not drawing? Y-axis. Those two forces are cancelling each other. That's not significant right now. We are only bothered about the x-axis. So now tell me, ma'am, force is acting on the right side, but M2 block is opposing it, correct? So what is that opposition? N12. And effectively it is moving ahead with an acceleration A, because the entire system is moving to the right with acceleration A. Okay. So now tell me, what is the equation, Newton's laws for this? Which is greater, F or N21? F, because the blocks are moving. So what will be it? F minus N12 is equal to, not A, force, right? A is acceleration, correct? Force, you should write force. What is force? M1 into A. Good. So F minus is it clear, students? F minus N12 is equal to M1 into A. Earlier we were doing for y-axis. Now we are doing for what? X-axis. What is N? I'll explain this once more. Listen carefully. What is this mass? M1. What is the force acting towards the right? F. What is the force acting opposite? The normal reaction here, N2. But effectively the body is moving to the right with an acceleration A. So can you tell me, students, what happens? F minus N12 is equal to M1A. The way you used to write, right, for the bulb, light bulb hanging, what you will do? Mg minus tension is equal to M1 MA, correct? Same thing you're doing in x-axis now. That's all. Force minus N12 is equal to M1A. That's all clear now. So what is F equal to? N12 plus M1A. Or in other words, what is N2? N12. F minus M1A. Okay, now let's write the free body diagram for M2 and tell me, guys. For M1 to M2, tell me, what are the forces? Does M2 experience F or not? Does M2 experience F? No, it won't experience F. F will be experienced by whom? M1 only. The impact of that is seen through N12. So what will M2 experience? N21, N21. And what it will be opposed by? N23, N23. Correct? Okay, let me write it down. So what is pushing it to the right? M1 is pushing it to the right, correct or not? That is N21. What is it getting back from M3? N23. All right, this side. But effectively it is moving to the right because all three bodies are moving to the right. So now tell me the equation now. What is the equation? N21 minus N23 is equal to M2 into A. That's all. But what is N21? Same as N12, correct or not? What is it going to be? F minus M1A, correct or not? So what is N23? So N23 will be F minus M1 plus M2 into A. Now what is N32? Come on, tell me. Last. Let's draw the free body diagram of M3. What are the forces acting on M3? There is only N32. Because of that, the body is accelerated. So what will be the equation? N32 equal to M3 into A. That's it. That's all. Now you can see, students, what we have derived. So contact force between M1 and M2, which is N12. What is N12? F minus M1A. F is nothing but what? M1 into M2 into M3, M1 plus M2 plus M3 into A. So what will cancel here? M1A, M1A will cancel. You'll get back what? M2 plus M3 into. That is the contact force between M1 and M2. Next, contact force between M2 and M3 is going to be M3A that we have derived here. Clear, students? Now we will move on. Want to quickly note down? I'll just give you a minute. Take it down. Because application of this will come in the next chapter also, rotational motion. And obviously you will have it next year also. So free body diagram, very, very important. And to be able to analyze the resultant force. The final answer, you can write it down here. N12 is M2 plus M3 into M2 plus M3 into A. How are we getting it? You're substituting the value of F from this. If you substitute your value of F here, you will get this answer. For M2 and M3, directly we have written M3 into A. Okay, students, shall we move on? Okay, ready? We'll move on now. Yes. Who would like to try? Sudarshan, can you try? Don't worry if it is wrong, no problem. Right or wrong doesn't matter. So now 16 kg, 8 kg, 4 kg are placed in contact as shown in the figure. Force of 140 Newton is applied on 4 kg block. Then what is the force on 16 kg block? Sorry? Acceleration will be equal, not force. I want to know the force on 16 kg block. So force will not be equal, right? 140 Newton is experienced by which block? Correct or not? So 16 kg will not experience 140 Newton. Acceleration will be same. That is a hint. Right. Find acceleration first. Tell me what is acceleration? How to find acceleration? I asked question to Shreyas, right? Tell me only the acceleration first. Can you tell? Yes, Jeevan. What is acceleration? 5. Correct. Very good. Now tell me what could be the force on 16 kg? You don't know. Sorry, I'll ask another question. See here. What is the you found the acceleration, right? What is the acceleration? 5. Now, what is the acceleration of 4 kg? 5. What is the acceleration of 8 kg? 5. What is the acceleration of 16 kg? 5. This body is at the end, correct? What is the force equal to? Mass into? What is its mass? What is the acceleration? What is the answer? 16 into 5. What is 16 into 5? 80. 80 is the answer. Okay, guys, give a good round of applause. Jeevan. Okay, ma. Very, very simple sum. Very, very simple sum. I'll tell you how to solve. All of you know this, right? We have explained this a couple of times. If you have a system which is moving, right? You're pushing this from here. Then all the three are moving together. What will be the acceleration of each block? Yes, Shreyas, what is the acceleration of each block? Yeah, same, correct? So what is the acceleration of 16 kg? 8 kg? 4 kg? So all of them will have the same acceleration. How did they get 5? Very simple. Force divided by total mass. What is the force? 140. What is the total mass? 16 plus 4, 20, 20 plus 8, 28. 140 by 28, 5. Correct? So 5 is the acceleration. Once you find 5, very simple. This mass does not have any opposing thing. Correct? 16 kg easy to find. Because nothing is opposing. Only its mass into acceleration is moving it further. So what is the mass? 16. What is the acceleration? 5. So what is the net force on 16 kg? 80 Newton. What is the net force on 8 kg? 40 Newton. What is the net force on 4 kg? 20 Newton. Because its mass into acceleration will be its net force. That's it. So what is the answer, students? 80 Newton is correct. So find the acceleration first. Acceleration is how much? What is A? 140 divided by 28, 5. 5 into 16. Answer over. 80. First to find the acceleration, then multiply with mass. Or you can use this formula. Okay? Don't worry about them. Shall we move on? Okay, now motion of body is connected by a string. Okay. So when two bodies of mass M1 and M2 are connected to ends of a string and are kept on a smooth horizontal surface pulled by a force F, then what will happen? Right, students? Now we were talking about them in contact. Now they are connected by what? String. So can you draw the free body diagram of M2? Forget the y-axis forces y. They cancel each other, they don't contribute to the motion, correct? So M2G is equal to R2. What is M2G? Weight of M2. What is R2? Normal reaction. Those two balance each other. So that it's not having any acceleration in y-axis. You are applying a force F here. Because you are pulling, M2 also moves, M1 also moves. Yeah. Now, can anybody tell me what is the acceleration of M2? A. What is the acceleration of M1? What is the acceleration of the system? Net force. What is the total force? F. Divided by total mass. What is the total mass? M1 plus M2. Now let's draw the free body diagram of M2. Along the x-axis you draw. Can you tell me what it is? What are the forces acting on M2? Capital F and tension. The body is moving to the right. So which force is greater? F or T? F is greater. So it's F minus T or T minus F? F minus T. What is F minus T equal to? M2 into A. Or T is equal to F minus M2A. You can substitute the formula for M2, F. So M1A plus M2A minus M2A. So M2 will cancel. You get M1 into A. Now let's draw the free body diagram of M1. What is the free body diagram of M1? What is tension equal to? Nothing is opposing. So tension equal to M1A. That's all. So tension is equal to M1 into A. A is nothing but what? F by M1 plus M2. So you're substituting the value of A here. That's all. Let's move on. Okay, now three objects are there. Now tell me, what is T1 going to be? Let's say, tell me the acceleration. What is the acceleration? Quick. F divided by M1 plus M2 plus M3. Excellent answer. Okay, next. What is tension T1? Simple answer. M1A, M1 into A. Very good. Then what about, yes, so first we'll see acceleration. So acceleration produced by the system is force divided by total mass. What is the force? F. What is the total mass? M1 plus M2 plus M3. Then what is tension produced in the first string, M1? T1 is equal to M1 into A. Instead of A, you substitute this F by M1 plus M2 plus M3. Next. Tension produced in the second string. What is it? E2. E2 is nothing but what? M2 into A minus T1. Correct or see here? T2 minus T1 is equal to M2A. Correct or not? I will draw the free body diagram so you'll understand. What is this mass? M2. What are the forces acting on it? Tension is pulling it in this way. What about T1? T2 is pulling it to the right. T1 is pulling to the. But still it is moving with an acceleration A. So how can you write this? T2 minus T1 is equal to M2A. But already we found what is T1. What is T1? M1A. So you can substitute there. So what is T2 equal to? M2A plus M1A. If you take A outside, what do you get? M1 plus M2. So what is T2? M1 plus M2A. Here we have found it based on in our what we did here before, right? We found it based on the second block. But in the third case, in the case what is shown here, it has been found based on taking the free body diagram of the third one. Anything you can do. So final answer you're getting what? Same. So T2 is M1 plus M2 into M. Is that clear, students? M3, one force is on, taking it to the right. What is pulling it back? What is pulling it back? E2, very good. F is nothing but T3. F is nothing but, they both are same. So T3 minus T2 is equal to M3A. So T2 will be nothing but T3 minus M3A. But what is T3? T3 is nothing but F. F already we know. What is F? Isn't it true? What is the acceleration? F by M1 plus M2 plus M3. So what is F equal to? So what is F equal to? M1 plus M2 plus M3 into A. Substitute that in the last equation. What is T3? T3 is nothing but what? F. Therefore, F is nothing but what will get cancelled? M3A will get cancelled so that you will get what? Same answer what you got there. That's also. Is it? F is T3, correct? F is T3. What is F? M1 plus M2 plus What is F1? M1 plus M2 plus M3 into A. You substitute that in place of P3. So what will cancel? M3A will cancel. You will get M1 plus M2 into A. Same thing we got even with the free body diagram of M2. That's what I'm saying. Both the ways we are getting the same answer. Quick. Who will answer this now? Can you try Ritu? 3 blocks of masses M1, M2, M3 are connected by a massless string as shown in the figure. They are pulled with a force of 40 Newton. Masses are 10 kg, 6 kg, 4 kg. What will be the tension T2? We just derived the previous case. T2 is what? M1 plus M2 into A, correct? What is A? Calculate A. What is A? Very good. Tell me A. What is A? Very good. Good. What is sum of all the masses? 20, right? What is force? 40. 40 divided by 20? 2. So acceleration is what? 2 meters per second square. Now, what is the expression for T2 we derived? M1 plus M2 into A. What is A? 2. What is M1? 10. What is M2? So 10 plus 6 into, what is the answer? 32. Is it there in the option? Which option? Yes. You go to round of applause. That's all. Very simple, students. First to find the acceleration. Once you find the acceleration, just whatever we did, right? M1A plus M2A you do, you'll get 32 Newton. Shall we move on? Okay. Torch mission, which is nothing but a pulley. Okay. So what are the two masses now? M1 and M2, which is hanging. M1 is greater than M2. Then what will be the equation? Just do the equation. Solving part we will not do now. Remember the result. Okay. For body A, can you tell me the free body diagram, ma? M1G will act downwards. What will be acting upwards? Tension. The body is coming down like this because M1 is more than M2. So what will be? Net force is equal to M1 into A. What is the net force? M1G minus tension. So M1G minus tension is equal to M1A. Now what about for M2? What is the free body diagram? What is acting? M2G downwards. What is acting upwards? Tension. Which is greater, tension or M2G? Tension. Why? Because moving up. So tension minus M2G is equal to M2A. So you have two equations, two unknown variables. What are they? Tension and acceleration. So once you solve it, you get A as M1 minus M2 into G by M1 plus M2, and tension is 2M1 M2 by M1 plus M2 into G. You try solving it in the break. If you do not get it, let me know, then I will solve it for you. Very simple. M1 is more than M2, so it is going to go down like this. M1G acts downwards, tension acts upwards, but still the body is coming down. Therefore, M1G minus tension is M1A. And similarly here, body is moving up. Tension acting in the upward direction, M2G in the downward direction. Tension minus M2G is equal to M2A. So when you solve the equation, you're going to get the value of A and T. Try it. If you do not get it, then we will help you out. Then finally, the reaction at the pulley. How many tensions are acting downwards? 2. What is the force upwards? FP. So the force on the pulley in the upward direction, that is called reaction. That will be equal to what? T plus T, how much? 2T. Okay, what's the time now? 11. So we'll take a break, students, 11 to 11:15. Come back. We have a couple of important things to cover. Number one, law of conservation of linear momentum. Very important question for your quarterly exam. Next, we will cover friction. Okay, we should get to friction as soon as possible. We may not be able to do all the important derivations which are going to be there, which will be covering on Monday, but all the concepts necessary for that will be done today. Okay, yeah, go for the break and come back soon.